What's up, everyone? It is a great day to learn about trigonometry transformations. Yesterday was not a good day for it. Tomorrow is not a good day for it, but today is the day. Let's get started. If we take a look, I want you to get this down in your notes right here. Okay, that's your formula for a trig function that has transformations applied to it. So what is A? A is going to be the amplitude. It's how far up the graph goes and how far down it goes. We'll explore that a little bit more. This B helps you calculate the period. The period has to do with how long it takes to complete a full cycle of your trig function. This minus C here is going to tell us if it's going left or right, if it's going to get shifted, and this D here is going to tell us if it's going to go up or down. Sometimes this horizontal shift is called a phase shift, but we're going to refer to it as a horizontal shift here. Now the same is true for the cosine function, which we will talk about, but we're not going to talk about the tangent function. We're not going to deal with graphing that. So let's just remember, how do we graph sine and how do we graph cosine? Well, first of all, we should remember that sine of 0 is 0. We should really start to just have this memorized. And then we should know that the sine graph kind of hits halfway and then goes back to 2 pi. Its amplitude is 1, and it always starts up if we've got a positive sine x. Okay, and then it goes down. So what I've got here is something like that. So again, I've got 0, 0 as my first point. We need to make sure we know that. We also need to know that our period is 2 pi, right? It takes all of 2 pi to get through the entire cycle. And also, did I mention this, that the amplitude is 1? We wouldn't say the amplitude is -1, although that is true that it goes all the way down to -1. We still would just say the amplitude is 1. And I could keep drawing this if you'd like, right? We could just kind of see that pattern that we're going to hit that x-axis like that. And you can kind of keep drawing that if you'd like. And I'll keep trying over here, just like that. All right, now cosine, what do you remember about cosine? Where does that start? If you said 1, you are correct. So cosine starts at 1. And then also just remember it's also a period of 2 pi, so it's going to end back at 1. And in the middle, we're down to -1. Okay, so you have something that starts like this. It's like that. I could...
Sorry, I didn't quite catch that.
Oh,
Please repeat it?
My Siri just went off. My apologies. All right, so we got something that looks like that. I'm going to redraw. I'm not sure I love that. All right, so it's going to look something like that. All right, and you could keep drawing this if you'd like. All right. So I'm going to have by my pi, I'll be down here. And then you could just jump if you'd like every 1, 2, 3, 4, 1, 2, 3, 4. I'm back up here, and you've got another one of these. Okay, I guess I should kind of turn this one here. It should be a little bit more. I don't know why. I guess I have a harder time drawing cosine than I do sine. All right. Let's talk a little bit more about amplitude. So amplitude of a trig function is the maximum displacement on the graph of that function. In the case of sine and cosine, the value is always going to be that leading coefficient. And you really should just take the absolute value of it right here because we're talking about a positive number of what displacement is. So in this particular case, for sine x, usually we start at 0, 0, right? Well, we still do that here as well, and we end at 2 pi, and we'll be at pi here, but how high we go and how low we go now changes, and I want you to get in the habit of doing a dotted line at 4, okay, and then a dotted line at -4 here. All right, and so instead of going up to 1 and then coming back down, we're actually going to go all the way up to 4, then go back down, and then I'm going to go all the way back down here. And we can repeat this whole pattern if you want, right? We can go 2 here, and then another 2 here. Remember, we're starting up, then going down, going back to here. So that's what amplitude is. It's that maximum displacement. It doesn't really change left, right, up, down, or the period. It just changes how high and how low the graph goes. So that's amplitude. Now let's talk a little bit about the period. The period of a function is the interval between the two matching points on the graph. In other words, it's the distance along the x-axis that the function has to travel before it starts to repeat its pattern. So if you look here, I have a full cycle of sine when I do this, right? It needs to go up and then needs to go kind of down and then back up. So this is a full cycle, and we should know that that takes 2 pi to complete that cycle. Now, we haven't seen this before, but to calculate a different period, because there's been a transformation, we have to look at this value right here. That's our b. And so that's our b, and our period is going to be equal to 2 pi divided by that b. Okay, so this is my b. So let's go ahead and calculate it. Let's find this. So my period is going to be equal to 2 pi divided by pi over 2. Now I'm going to simplify this. If I'm dividing by a fraction, that is equal to rewriting the 2 pi, but then multiplying by the reciprocal of the denominator. So that's going to be, what's the reciprocal of pi over 2? It's 2 over pi. Okay, so the pi's cancel here, and I'm just left with a period of 4. Now that might freak you out a little bit, right? Because we're usually used to graphing sine and cosine with 2 pi and pi over 2, and now I'm saying, hey, actually it's done after 4. So here we can see, oh, okay, my sine starts at 0, 0, 0. It's going to end at 4. It's going to do a full cycle by 4. And we know at the halfway point, it kind of crosses through the x-axis. There is no change in our amplitude. It's just a 1. So we are just going to go up to 1 and then down to 1 and back up. And we can continue this pattern if you'd like. If you kind of want to do one more, and I will probably ask you to do more than one period on your homework or on a test. Okay, so there we go. And this might feel like, hey, Miss Sorensen looks exactly the same, but actually, remember, we're usually ending at 2 pi, and 2 pi is 6.28, right? This is actually ending at 4. So it is different. All right, now let's just talk about the vertical shift, the horizontal shift, and the fact what if we have a negative out in front, kind of what happens there. Let's deal with that negative situation first, all right? I'm just going to quickly draw a sine again. We really need to have this down anyway, so just a quick review. So that's going to be up to 1, down to -1, up to 1, down to -1, just like that. I'll put some arrows because it does continue on. Negative sine x is actually going to reflect this over the x-axis. All right, what I want you to do, let's just focus on one period at a time here. Let's focus on this. I went a little too far there. Okay, let's just focus on that. Did it again. All right. So for one period, if I'm going to have a negative sine x, that actually gets reflected over the x-axis. So notice here that we start up. Well, actually, if we were to reflect that over the x-axis, I should get this. Do you see that? Do you see how this reflected over the x-axis becomes this? All right. And then here, I'm below the line. If you reflect that over the x-axis, it actually comes up above, just like that. Okay, so I don't love thinking about it as reflecting over the x-axis. Instead, what I like to think about is the fact that it actually is now going to start down and then go up. Okay, do you notice how on this one, we actually, looking at the start here, it starts up and then goes down. if we have a negative sign of x, it starts down and then goes up. That's the way I like to memorize it. All right. If you want to memorize it as reflecting over the x-axis, if that's easier for you, I'm game for that too. All right. Now let's talk about this. Holy moly, we've got a negative pi over 2 and a plus 1. Well, we spent a heck of a lot of time on problems like this. We should know that the inside the parentheses is the left/right, and the outside of parentheses is the up/down. Now, we also should know that it's the opposite of what you think it should be inside the parentheses. You would think, oh, it's negative, that should be left. That's not correct. Remember, it's the opposite of what we think. So this would be a situation where we actually go right pi over 2. And then here we've got a situation where it's on the outside. This is exactly what you think it should be, right? It should be up 1. So just to summarize, here because it's minus, it's going to be right. And here because it's plus, it's going to be up. So the inside's the opposite of what you think it should be. It's either left or right, and the outside is what you think it should be. It's up or down. All right, so let's go ahead and graph this. We should have to kind of refer back to our original parent function. So sine of x starts at 0, 0, but I'm actually saying, hey, you need to go right pi over 2 and up 1. So I actually need to take this point and go right pi over 2 and then up 1. So it gets moved to right here, and I need to erase that original point. And then from there, you know, I wouldn't even keep moving points. I would just say to myself, oh, I know that every 2 here, or every pi, I'm going to hit the x-axis. So I'm going to go like this and then like that. I know it's going to start up because we've got a positive here. So it's going to start up. It's going to go up only to 1, and then it's going to go down 1, and then it's going to go here. And we can go ahead and just repeat that pattern. I do like to do more than one period. So this is going to be up, and then I'm going to go down, and don't forget your arrows. And so this whole entire graph compared to this one right here, if I were to do this red box around my first period here, you should see that, here I go right here. Oops, sorry about that. Okay, that whole box has pretty much been shifted right pi over 2 and then up 1. Notice how this box is actually below the x-axis and this one's on it. And then you can see that this line right here is on the y-axis, and now I've actually been shifted over to the right pi over 2. All right, let's kind of put everything together. And I want to go kind of problem by problem, going straight down each of these to see kind of where we're at. So let's start with this one. What does the negative do here? Well, that's going to do a reflection over the x-axis. So that negative is saying reflect over x-axis. Okay, so we've done that. And then what about the next one? Well, that's going to tell us our amplitude. That's going to be an amplitude of a equals 2. All right, next up, I'm going to skip the pi over 2 for now. Let's deal with the minus 4. That's going to be a horizontal shift, and that is going to be the opposite of what you think. It's going to be a right 4. And then this one right here, that is our vertical shift, and that's going to be up 2. Now, let's go back. We didn't answer the period, but the period's a little bit more work. The period is going to be equal to always 2 pi divided by our b. What's our b? It's pi over 2 in this situation. So that becomes 2 pi times 2 over pi, because remember, we multiply by the reciprocal. Here our pi's cancel, and we're left with a period of 4. So we have, in fact, answered all that we want. We have our vertical shift, we have our horizontal shift, we have our amplitude, we have the fact that it's reflected over the x-axis, and we've got the period. All right, let's do the next one. So the next one, we don't have a negative, so there's no reflection over the x-axis, so we skip that. But we do have an amplitude of 4. we do have a left 1, we have a down 3, and now we got to deal with our period. So here's our b. So we've got to do 2 pi over my b. Well, my b is 2. And 2 pi over 2, the 2's cancel, and I'm left with pi. So my period in this particular problem is pi. All right, last one. We do have a negative here, so this one is reflected over the x-axis. All right, our 1/2 is going to be our amplitude, so it's going to be kind of shrunk or kind of smushed, if you will. Our amplitude is 1/2. We'll go back to the b in a second. This is going to be a left pi, and this one is going to be a down 1. Now let's deal with our b, so that our period is going to be 2 pi, always 2 pi divided by pi over 4. That's going to be equal to 2 pi times 4 over pi. Our pi's cancel, and I'm left with 8. 2 times 4 is 8, so my period is equal to 8. So I've got my amplitude, I've got my left pi, I've got my down 1, I've got my reflected over the x-axis. Looks like I've covered everything. That's it for video 14. I was kind of a blast, don't you say? Like, you kind of want to watch it 5 more times? I hear ya. I totally hear ya. Have a great day, and don't forget to do your assignment.